Okay, good afternoon. What I'd like to do is talk about the factory side of last crop. First and foremost, I'd like to say we had an excellent crop. The cane grounds of 17 million was a record. The sugar made of over 2 million tons was the first time, and that's a record. Molasses production was over 108 million gallons. And that was in spite of losing about 60,000 tons of sugar that we would have made had we not had the freeze. This is a slide of cane ground over the years, going back to 1979. And you can see the last crop was the most cane we ever ground. If we look at sugar production, same kind of thing. We used to be much lower. We've been on an increasing trend of sugar production, and last crop was the highest. If we look at sugar yield per gross ton, that's been on a steady upward trend. Last year had a little dip, primarily because of the freeze. Grinding rate, normally we've been increasing in grinding rate over the years, and we went along pretty well up until last crop, until the freeze, and you can see we had a little dip from the previous year because of the problems we had at the end and a few problems at the beginning. This is a look at the grinding rate for the last two crops. The blue line is 2021. The red line was last crop, 2022. You'll notice we were pretty much on track all the way through until close to the freeze, and then there was a divergence where the previous crop was better, and this last crop we didn't grind as fast at the end. There were two minor freezes initially, one in October, one in mid-November, and then we had the big freeze 2 days before Christmas. This is a look at the sugar yield over the crop, and I have 3 decades and 2 crops on here. The lowest blue line is the decade from 1991 to 2000, and you can see fairly flat over the crop, and the crop ends fairly early. The next line, the green line, is for the next 10 years from 2000 to 2010, and it's slightly better, a little higher. And then the most recent decade from 2010 to 2020, that's the, I guess it's purple line here. And you'll notice over the years we've been getting better on sugar yield over the crop. The next 2 lines on top are, the yellow line is the 2021 crop. And you'll notice on that the sugar yield started good, stayed well, and to the end of the crop, middle of January, was still increasing. That's because we didn't have rain and we didn't have a freeze that year. The dashed red line was last crop. We started higher than the previous crop, which was an excellent crop on sugar yield. We were about 20 pounds per ton higher this last crop, up until we had the weather issues. And you can see after the weather issue here, especially the second moderate freeze, the sugar yield did not increase anymore. In fact, it started declining down here. And then when we had the December freeze, pre-Christmas freeze, that's when it really fell off. If we look at how much molasses was made, at the beginning we made a lot of molasses because we had high sugar content and normal purity, so we had more molasses in the cane. As the cane matured, purities increased, sugar yields, molasses yields declined, and then after the freeze, then we had a big increase in the final molasses, some mills going over 20 gallons per ton at the end. if we look at crop length, these are the 11 mills in the state. From the top one, the shortest crop, they ended long before the Christmas freeze. All of the rest ran a lot longer, and 5 of the mills went into mid-January, mid to the 3rd week in January. Those are the ones I'm going to concentrate on later. The main issues I had in the factory were cane sampling, core lab and factory lab juice analyses, cane milling, lime usage, sugar boiling, sugar centrifuging, and molasses handling at the end. There were no issues with juice heating, juice clarification in the factory, evaporation, crystallizers, or boilers. This is a look at, this is from the literature, a typical picture of normal sugar crystals. And you notice they're pretty much square. At the beginning of the crop, we had these elongated crystals for several weeks. This slowed factory operations down and did cause a little bit of problems at the centrifugals, not much. By middle of the crop, the grains in the pans looked much more regular. These are still slightly elongated, but really very good. And then at the end of the crop, after the freeze, we started seeing elongation again in the crystals. That slowed things down again. At the core lab, the main issue they had was on frozen cane, you couldn't press the juice out of it directly. You had to thaw the cane first because the ice crystallized, the juice that remained was concentrated, and the numbers you would get from the core lab were false unless you thawed the cane first. There were some issues with clarification in the lab and in the factory lab with clarifying the juices. Tried different clarifying agents, but in general, most factories had no issues. Milling. Milling, there were long periods, as you saw before, where the cane was frozen. Frozen cane doesn't go through the mill very well at all. So several factories tried to thaw the cane. One of them turned on the cane wash water system that was not being used at the time to try and defrost the cane. But that didn't work too well, so they went to switch to hot water on the belt conveyor, feeding their shredder. Other mills used hot water, and in one case also hot clarified juice added directly into the Donnelly chute feeding the first mill. That seemed to work fairly well. Along with the frozen cane, there was a lot of concern that DEXTRAN would be a big issue. So DEXTRANASE treatment was thought to be a major operation. And the main items are the DEXTRANASE that's used to remove the DEXTRAN is very expensive. It's about over $20,000 per drum. So you want to use it effectively or optimally. The recommended maximum best conditions, optimum conditions are 120 degree F juice temperature and a pH of 5.8 to 6. One factory essentially achieved those. They operated with 120 degrees, a pH of 6, and they had a 10 to 12 minute retention time, and they were able to remove 80 or 90% of the DEXTRAN in the juice. Another mill went with between 120 and 130 degrees. The pH was variable. It was manual or fairly manual control. They varied from 4.5 to 6 pH. They had 8 to 10 minutes of retention time, and they achieved 50 to 60 and up to 80% DEXTRAN removal. Another mill was able to heat the juice only to 106. pH was manual control. They had very little retention time, and they had minimal dextran removal. The other couple of factories operated with ambient juice temperature, which was very low, ambient pH, which was too low, very little retention time, and once again, they had minimal dextran removal. This is a look at the dextran for the whole state factories over the full crop. You'll notice the penalty level is somewhere between 200 and 250, and we had nobody, the state never averaged above penalty level until after the freeze. After the freeze, here, we had the last 3 weeks of the crop with very high dextran and sugar, in spite of all the effort to remove dextran that we talked about in the previous slide. If we look at the crusher juice pH, that's fairly normal, and this slide is from 12th of December until the end of the crop for the 5 factories that went to past mid-January. pH control here was fairly normal. That's what came in with the cane. After the freeze, after about a week and a half, the pHs started dropping, and at the end, some of them got down to under 4. One of the effects of the low pH was lime usage. Lime's used to neutralize the acidity in the cane and also to create precipitates and clarify the juice. But after the freeze, lime requirements doubled and tripled. Some factories actually used some soda carbonate as an alkali so they didn't have to use as much lime. One factory had to increase the concentration at which they put lime in the process because their automatic control equipment wouldn't deliver enough unless they concentrated the lime before adding. If we look at the syrup purity, that ran around 85 to 90 for most of the crop. After the freeze, about a week or two after the freeze, the purity started dropping and dropped down very low at some factories. These are the ones that were handling the worst cane from the northern areas. And the most southern factories, they had less deterioration, and they didn't get to as low syrup purities at the end. Sugar boiling. That was probably the station of the factory that was most affected. And following the freeze, cool weather initially didn't allow too much deterioration. But once the weather started warming up, as you saw with those high temperatures post-freeze, dextran levels increased, and especially gums increased. The lower purity syrup necessitated modifications to the boiling scheme. First of all top-off boilings were stopped. Secondly, some of the factories had to go to a 2.5 boiling scheme. And when the purities of the syrup got even lower, they switched to a full 2 boiling system. The C massicrete purities were raised. This is an attempt to the second one is the magma purities were raised, especially the C's, up to about 90 purity. The idea being to put these high purity materials back in the syrup and raise the syrup purity. After the freeze, the syrup purities started dropping by about 1/2 to 1 full purity point per day until they reached about 60 purity by the end of the crop. The dextran and/or the gums caused boiling times to be increased by about 25 to 30% of normal. One factory added soda ash to the pans and reported some improvement. Other factories applied surfactants or increased their dosage rate. Some factories increased the temperature in the pans. One factory tried acid addition to the massacreed. Most factories had to release some B molasses to the final molasses storage at some point during the grinding. Centrifuging. Centrifuging the lower purity gummy massacreeds presented some problems. The typical or the large centrifugals that the mills have been adding recently were very problematic in handling the massacreeds that were gummy. They were vibrated, they got out of balance, and they had problems plowing, and several of the factories quit using them completely. The smaller and older centrifugals, the 48 by 36s and 48 by 30s, were much better at handling poor quality massacreeds. Even the smaller centrifugals had to be operated at longer spin times and with greatly reduced charge. Instead of a normal 6-inch charge, you might only be running it with 3 inches. And of course, they needed some more water also to maintain the sugar quality. Molasses handling. The large quantity of molasses produced from the low purity syrup coupled with the large cane crop resulted in a lack of final molasses storage. Some factories had to slow down because of that. And several factories had to find off-site storage and ship molasses using a fleet of trucks to prevent the molasses tanks from overflowing. Miscellaneous. One factory tried 24 hours cutting and hauling for the last week or thereabouts. Another thing that some of the mills noticed was there were acid condensates. In other words, the water boiled out of the juice at the evaporators contained acids that were present in the juice, and this was similar to what was noticed back when we used to have hard-to-boil massacreeds around 2002, 2003. Conclusion. Despite elongated crystals at the start of the crop and post-freeze issues at the end of the crop, a record amount of cane was ground and sugar and molasses produced. Finally, I'd like to thank the 5 factories especially that went the longest for providing data and discussions. Belisario Montes, Adan Zapata, Kevin Gast, Fikadu Bien, and Tony Labrada. Thank you.